Hello everyone, hope you all are well. Today I will discuss about filter circuit, and I have divided it in two parts, part 1 and part 2. You will get the part 2 section in my description section. So if you go through these part 1 and part 2, I think your idea about filter circuit will definitely clear. So myself Mr. Santanu Noskar, Assistant Professor of Electrical Department, GKCM JIS Group, and my mail ID is santanu.uyt@gmail.com and santanu.noskar_gkcm@jisgroup.org. And this is my Facebook page, Being Electrify with Santanu. You can get all the lecture in my Facebook page and also in my YouTube channel. So before starting this lecture, I want to share with you something that was told by Aristotle, that the root of education are bitter but the fruit is sweet. So let's talk about your syllabus. So name of the course is Electric Circuit Theory, course code PCEE 301, semester 3rd, and there are 3 hours per week theory class, and tutorial is 1 hour per week, and practical 2 hours per week. Credit points 4+1. So about this objective I have already discussed in my previous classes. So I have in this content I have already covered all the things: introduction part, graph theory, coupled circuit, Laplace transform, network theorem, two-port network analysis, and today I will discuss about filter circuit. After this I will discuss about Fourier's method. So let's start. What are filters? So filters are electronic circuit that remove any unwanted component or features from a signal. In simple word, you can understand it as the circuit rejects certain band of frequencies and allows other to pass through. They are widely used in instrumentation, electronics and communication system, especially in signal and image processing. So in this video I will discuss briefly about the filters, its classification, characteristics, types, application, advantages, disadvantages, etc. So let's discuss briefly. Filters are essential building blocks of any electronics and communication system that alter the amplitude and phase characteristics of a signal with respect to frequency. So filter is basically linear circuit that helps to remove unwanted component such as noise, interference and distortion from the input signal. So ideally filter alters the relative amplitude of the various frequency component and the phase characteristics, and its gain depends entirely on the signal frequency. So a filter is defined by their frequency domain effect on signals, which is often described mathematically in terms of its transfer function, and it's expressed in the ratio of the Laplace transform of its output and input signal. So the voltage transfer function Hs of a filter circuit written as Hs is equal to V out S and V in S, where V in S equals to input signal, V out S equals to output signal, and S is the actually complex frequency variable. So by replacing the variable S in the above equation with j omega, where j is equal to root over -1 and omega is the radiant frequency, which is 2 pi f, and we can find the filter effects on the magnitude and phase of the input signal. Is the magnitude is found by taking the above value of the equation 1 is now H j omega equals to V out j omega and by V in j omega, or we can write this phase. This is the phase. So look here, this is the block diagram of filter circuit. AC input waveform, filter circuit output waveform. So if we classify this filter circuit, filter is mainly classified into two types: active filters, the filter circuit which consists of active components like transistor and op amps in addition to resistor and capacitor, is called as active filter. And what is passive filter? Filter circuit which consists of passive components such as resistor, capacitor and inductor is called as passive filter. The operating frequency range of the filter banks on the component used to build the circuit. Hence, a filter can be further categorized based on the operating frequency of a particular circuit, and they are low pass filter, high pass filter, band pass filter, band stop filter, and all pass filter. So let us discuss about this all type of filter. So first, low pass filter. So it is a type of filter which attenuates all the frequencies above the cutoff frequency. It provides a constant output gain from 0 to cutoff frequency. So this is the cutoff frequency FC, and this is the actual characteristics of low pass filter, and this is the ideal characteristics of low pass filter. So this is a pass band, stop band, pass band, stop band. So actual characteristics, ideal characteristics. Now go through high pass filter. So it is a type of filter which attenuates all the frequencies below the cutoff frequencies. It provides a constant output gain above the cutoff frequency. So look here in this picture, this is the cutoff frequency, this is the stop band, this is the pass band, this is actual characteristics, and this is ideal characteristics. Okay. So next, band pass filter. So it is a type of filter which allows specific band of frequency to pass through, and all other frequencies outside the band are attenuated. So look here, this is band pass filter characteristics, the stop band, pass band, lower cutoff, upper cutoff. Okay. Now band stop filter. So specific band of frequencies get rejected and allow passing of frequency outside the band. So this is the characteristic of band stop filter, lower frequency, upper frequency. This is also known as band rejection elimination filter or notch filter. Okay. Next, all pass filter. So it is a type of filter which passes all the frequencies equally. It is also known as phase shift filter, time delay filter, as the output voltage shift in phase with respect to input voltage, but they are equal in magnitude. Okay. Look here, this is the phase shifted phase. So this filter also known as phase shift filter and time delay filter, or simply the delay equalizer. Okay, so one major application of an all pass filter is the simulation of a lossless transmission line. The magnitude of the output voltage is same as the input voltage, but the output voltage is shifted in phase with respect to the input voltage. Next, the application of filter. So filter circuits are used to eliminate background noise. They are used in radio tuning to a specific frequency. It is used in pre-amplification, equalization, tone control in audio system, and they are also used in signal processing circuit and data conversion. And also filter circuits are extremely and extensively used in medical electronics system. Now we will discuss about the advantages of filter. So they are economical or cost effective. Unlike passive filter circuit, active filters require power supply. And disadvantage of filters: the circuits are bulky, limited bandwidth, and increased sensitivity to variation circuit parameter. Okay, so next we will discuss about all type of filter. Before this, we have to know what is capacitive reactance. Capacitive reactance is the complex impedance of a capacitor whose value change with respect to the applied frequency. In RC network, which I have discussed earlier, RC network, we saw that when a DC voltage is applied to a capacitor, the capacitor itself draws a charging current from the supply and charge up to a value equal to the applied voltage. So likewise, when the supply voltage is reduced, the charge stored in capacitor and also reduce the capacitor discharge. But in an AC circuit in which the applied voltage signal is continually changing from a positive to a negative polarity at a rate determined by the frequency of the supply, as in the case of a sine wave voltage, for example, the capacitor is either being charged or discharged on a continuous basis at a rate determined by the supply frequency. Now, as the capacitor charge or discharge, a current flow through it which is restricted by the internal impedance of the capacitor. This internal impedance is commonly known as capacitive reactance and is given by the symbol Xc in ohm. Unlike resistance which has fixed value, for example 100 ohm, 1 kilo ohm, 10 kilo ohm, this is because resistance obeys Ohm's law. But capacitive reactance varies with the applied frequency, so any variation in supply frequency will have a big effect on the capacitor and capacitive reactance value. So as the frequency applied to the capacitor increase, its effect is to decrease its reactance measured in ohm. Likewise, as the frequency across the capacitor decreases, its reactance value increases. This variation is called the capacitor's complex impedance. Okay, complex impedance exists because the electrons in the form of an electrical charge on the capacitor plate appear to pass from one plate to other more rapidly with respect to varying frequency. So as the frequency increases, the capacitor passes more charges across the plates in a given time, resulting in a greater current flow through the capacitor, appearing as if the internal impedance of the capacitor has decreased. Therefore, a capacitor connected to a circuit that change over a given range of frequency can be said to be frequency dependent. Now, capacitive reaction has the electrical symbol of Xc and has unit measured in ohm, the same as resistance, which is R. It is calculated using the following formula: Xc equals to 1 by 2 pi f. This is the capacitive reactance formula, where Xc is capacitive reactance in ohm, pi equals to 3.142 decimal value, and 22 by 7 fraction value. F is frequency in hertz. C is capacitance in farad. Now just go through an example. Calculate the capacitive reactance value of a 220 nanofarad capacitor at a frequency of 1 kilohertz and against at a frequency of 20 kilohertz. So at a frequency of 1 kilohertz, this is the value. Xc equals to 1 by 2 pi fc. The value is 723.4 ohm, and again at frequency of 20 kilohertz, the value of Xc equals to 36.2 ohm. So where F equals to frequency and C the capacitance in farad, therefore it can be seen from the value the frequency applied across the 220 nanofarad capacitor increases from 1 kilohertz to 20 kilohertz. Okay, its reactance value Xc decreases from approx 723 ohm to 36 ohm. The value decreases, and this is always true as capacitive reactance Xc is inversely proportional to frequency, with the current passes by the capacitor for a given voltage being proportional to the frequency. So for any given value of capacitance, the reactance of a capacitor Xc expressed in ohm can be plotted against frequency. Look here. So this is capacitive reactance against frequency. By rearranging the reactance formula here, we can also find at what frequency a capacitor will have a particular capacitive reactance. Okay, so this is the capacitive reactance. Now one thing to remember and discuss that register in series, that difference voltage can appear across each register depending upon the value of the resistance, and that a voltage divider circuit has the ability to divide its supply voltage by the ratio of R2 by R1 plus R2. Therefore, when R1 equals to R2, the output voltage will be the half the value of the input voltage. Likewise, any value of R2 greater or less than R1 will result in proportional change to the output voltage. So this is a voltage divider circuit considered here. Now we know that a capacitor reactance XC, actually it's a complex impedance. The value change with respect to the applied frequency. If we know and we now change resistor R2 above for a capacitor, okay, the voltage drop across the two components would change as the frequency changed, because the reactance of the capacitor affects its impedance. Now the impedance of resistor R1 does not change with frequency. Resistor are of fixed value and are unaffected by frequency change. Then the voltage across resistor R1, and therefore the output voltage is determined by the capacitive reactance of the capacitor at a given frequency. This then result in a frequency dependent RC voltage divider circuit. With this idea in mind, passive low pass filter and high pass filter can be constructed by replacing one of the voltage divider resistor with a suitable capacitor as shown in this figure. Look here, we just replace it a capacitor. Okay. Now for low pass filter, the property capacitive reactance makes the capacitor ideal for use in AC filter circuit or in DC power supply, smoothing circuit to reduce the effect of any unwanted ripple voltage as the capacitor applies an short circuit signal, okay, which pass to any unwanted frequency signal on the output terminal. Now for the summary, just summarize the thing, what is capacitive reactance. Now we can summarize the behavior of a capacitor in a variable frequency circuit as being a sort of frequency control resistor that has a high capacitive reactance value, okay, at a very low frequency, and low capacitive reactance value which is short circuit condition, and high capacitive reactance value in open circuit condition. Always remember that. So at a very high frequency as shown. So it is important to remember these two conditions, and in our next topic about the passive low pass filter, we will look at the use of capaciting reactance to block any unwanted high frequency signal while allowing only low frequency signal to pass. Now I will discuss about passive low pass filter. So about passive low pass filter, active low pass filter, passive high pass filter, active high pass filter, passive band pass filter, active band pass filter, all pass filter, what is decibel, all these things you will get in my part 2 and part 3 section. Okay, so please go through my part 2 and part 3 section also, which you will get in my description section. Now I will discuss about some reference book which are Circuit Theory Analysis and Synthesis by Abhijit Chakraborty. This book is very good book for diploma and BTech engineer, and you can clear your idea very easily by this book. Then Circuit and System by K.M. Soni. This is a very compact book for diploma and BTech engineers. According to my choice, this is the best book for BTech engineers. Next, Circuit Theory and Network by S.P. Ghosh and A.K. Chakraborty. This is also a very easy and good book. So thank you. If you have any query, then comment in my comment box, and another part of this video, please go through my description section. You will get all the other parts. So please subscribe my YouTube channel and stay safe and stay happy.